The Soviet Union emerged from World War II with factories in rubble and no jet engine it could call its own. The MiG-9 was the answer to that humiliation. First flown on April 24, 1946, powered by reverse-engineered German BMW 003 and Junkers Jumo 004 engines stripped from captured aircraft, it was a jet fighter built on borrowed technology. Its armament was a single 37mm cannon flanked by two 23mm guns, a combination that looked devastating on paper. The problem was that firing all three simultaneously at low speed risked flaming out both engines. Pilots learned quickly to pick their moment. 610 were built. It was never exported in meaningful numbers, never fought a war, and was obsolete before the production line cooled. The mig-9 did not define Soviet aviation. It proved the Soviet Union could enter the jet age at all, which in 1946 was the only proof that mattered. On November 1, 1950, American pilots over Korea encountered something nobody in Washington had fully anticipated. A swept-wing Soviet jet fighter that could climb faster, fly higher, and reach speeds that the straight-wing American aircraft of the era could not match in level flight. The mig-15 had entered service in 1949, and it changed the Korean War the moment it appeared. Powered by a Klimov VK-1 engine producing 5,950 pounds of thrust, derived directly from the Rolls-Royce Nene that Britain had sold to the Soviet Union in 1947, it reached 670 miles per hour and climbed to 50,000 feet. Armed with one 37mm and two 23mm cannons. Over 13,000 were built across the Soviet Union, Poland, and Czechoslovakia, making it the most produced jet combat aircraft in history to that point. The West had sold the Soviets the engine that nearly cost them the war. Britain never fully resolved how it felt about that decision. The mig-15 had a compressibility problem. Push it into a high-speed dive and the controls reversed. The aircraft could kill its own pilot before any enemy had the chance. The mig-17 fixed that. A more sharply swept wing, a longer fuselage, a redesigned tail, and the result was an aircraft that remained controllable where the mig-15 had become dangerous. First flown in 1950 and entering service in 1952, the mig-17 reached 711 miles per hour. Over 10,000 were built across multiple nations. In Vietnam, it flew against aircraft a full generation newer and achieved results that shook American confidence in missiles as the sole future of air combat. North Vietnamese pilots in mig-17s forced American crews to relearn dogfighting they had been told was obsolete. An aircraft designed to fix a control problem ended up exposing a doctrine problem instead. The Soviet Air Defense Forces needed a dedicated interceptor in 1950. Not a fighter adapted for interception. A purpose-built machine designed from the first drawing to find and kill American bombers before they reached Soviet cities. The Yakovlev Yak-25 was that machine. First flown in 1952 and entering service in 1955, it carried two crew members in tandem, a pilot and a radar operator whose entire job was to find the target and call the shot. Twin Michelin AM-5 engines producing 4,630 pounds of thrust each. Two 37mm cannons. A radar in the nose that could actually locate bombers at night and in bad weather. Range exceeding 1,700 miles. Around 480 were built. The Yak-25 established what a Soviet interceptor was supposed to be. 2 men, 1 radar, 1 mission. Find it before it finds you. The Soviet Union crossed the sound barrier on September 5, 1953. And the aircraft that did it entered production as the mig-19. The first Soviet fighter capable of supersonic speed in level flight, not just in a dive. 2 Michelin RD-9B afterburning engines producing 7,165 pounds of thrust each pushed it to Mach 1.3. 3 30mm cannons. Equipped with early air-to-air missiles and later variants. Over 2,500 were built in the Soviet Union, with China producing thousands more as the J-6, a copy that outlasted the original by decades. Chinese J-6s were still flying combat patrols in the 1990s. The mig-19 proved the Soviet aviation industry could design for supersonic flight, not just adapt to it. That distinction would matter when the next generation arrived. More air forces flew the mig-21 than any other supersonic fighter in history. Over 11,000 were built across the Soviet Union, India, China, and Czechoslovakia. It entered service in 1959 as a point defense interceptor with a delta wing, a single Tumansky R-11 engine producing 13,120 pounds of thrust with afterburner, and a top speed of Mach 2.05. It carried two K-13 missiles copied directly from an American AIM-9 Sidewinder that Taiwan had provided to the Soviets after a failed Chinese engagement. The aircraft that armed the mig-21 had been designed to kill it. In Vietnam, mig-21s flew against F-4 Phantoms and achieved results that forced the United States to reopen Top Gun. In the Middle East, India, Africa, and a dozen smaller conflicts, the mig-21 kept fighting wars its designers had not anticipated and kept finding targets its critics had underestimated. It was not the best fighter in any of those theaters. There were simply more of them than anything else, which turned out to be its own form of superiority. Pavel Sukhoi designed the Su-7 as a high-speed interceptor. The Soviet Air Force took one look at it and turned it into a ground attack aircraft instead. The interceptor never served in that role. The ground attack variant became one of the most widely exported Soviet combat aircraft of the Cold War. First flown in 1955, the Su-7 used a single Lyulka AL-7F engine producing 19,840 pounds of thrust with afterburner, and reached Mach 1.6. It carried two 30mm cannons and external stores on four wing pylons. India flew it in the 1971 war with Pakistan. Egypt flew it in 1973. Afghanistan, Algeria, Iraq, North Korea, and Poland all operated it. Over 1,800 were built. The aircraft Sukhoi had intended for one mission spent its entire career performing another, doing it well enough to remain in frontline service through the late 1980s. The interceptor that became a strike jet. Both roles worked. Neither was what he planned. The gun was gone. Every Soviet interceptor before the Su-9 had carried cannon. The Su-9 entered service in 1959 armed exclusively with four K-5 air-to-air missiles guided by the RP-9U radar in the nose. The reasoning was straightforward. Bombers crossing Soviet airspace at high altitude and high speed would be moving too fast for a gun engagement to develop. Missiles would reach them before a pilot could close to cannon range. The Lyulka AL-7F engine produced 19,840 pounds of thrust with afterburner. Top speed exceeded Mach 1.8. Service ceiling reached 59,000 feet. Around 1,150 were built, serving the Soviet Air Defense Forces through 1981. The pilots understood the logic behind removing the gun. They spent 17 years disagreeing with it anyway. No fallback when the missiles failed. The Su-9 served reliably in the systems it had and uncomfortably in the one it lacked. NATO called it the fire bar and the name suited it. The Yakovlev Yak-28P entered service in 1962 as a long-range, all-weather interceptor designed to patrol the vast stretches of Soviet airspace that shorter-ranged aircraft could not reach on a single fuel load. Twin Tumansky R-11 engines buried in the wings produced 13,670 pounds of thrust each with afterburner. Top speed exceeded Mach 1.9. A crew of two, pilot and radar operator, working the Oriol-D intercept radar to find targets at night and in weather that grounded everything else. Around 437 were built. The Yak-28P defended Soviet airspace across the Arctic approaches for nearly 2 decades, patrolling routes that American bombers would have used if the Cold War had ever gone hot. It never fired its missiles in anger. The routes it patrolled were never tested. That was considered success. No interceptor ever built was larger. The Tupolev Tu-128 entered service in 1964 with a wingspan of 57 feet, a length of 98 feet, and a maximum takeoff weight of 97,000 pounds. It was powered by two Lioka AL-7F2 engines producing 22,046 pounds of thrust each with afterburner, and reached Mach 1.65. The Tu-128M variant introduced upgraded avionics and the R-4 missile system, for missiles on 4 pylons, each capable of reaching targets miles ahead without visual contact. Around 188 were built, all operating with the Soviet air defense forces across the enormous distances of Siberia and the Arctic, where no smaller interceptor could sustain the patrol ranges the mission required. The pilots who flew it called it the Tomcat, their own name, years before the American Navy used the same word for a different aircraft. It was not agile. It was not a dogfighter. It was a flying radar station with missiles attached, and in the airspace it patrolled, agility was never the point. On September 1, 1983, a Su-15TM of the Soviet Air Defense Forces fired 2 missiles at Korean Airlines Flight 007 over the Sea of Japan. The Boeing 747 was destroyed. All 269 people aboard died. The Su-15 had been designed for exactly that mission. Find a high-altitude intruder, close to engagement range at maximum speed, and fire before the target could maneuver. It had done precisely what it was built to do. First flown in 1962 and entering service in 1967, the Su-15 used 2 Tumansky R-13 F-300 engines producing 14,550 pounds of thrust each with afterburner. Top speed reached Mach 2.5. The Typhoon radar in the nose could find targets at distances that earlier Soviet interceptors could not approach. Over 1,400 were built. The aircraft answered only the question it had been designed to answer. The political consequences were not part of its specification. The swing wing promised everything: high-speed performance with swept panels, low-speed handling with wings spread forward, and the flexibility to perform both missions in a single flight. The mig-23P was the dedicated interceptor variant of the mig-23 family, entering service in 1975 with the SAP-23 radar and R-23 and R-60 missiles replacing the ground attack systems of its stablemates. The Cockatoo R-29 300 engine produced 27,557 pounds of thrust with afterburner. Top speed exceeded Mach 2.35. Over 5,000 mig-23s of all variants were built, the most produced variable geometry aircraft in history. The interceptor version served with Soviet air defense forces through the late 1980s. Syria flew them against American aircraft over the Gulf of Sidra. Libya flew them and lost. The swing wing solved the aerodynamic problem. It created a maintenance problem that never went away. Complexity always finds a way to present its invoice. In 1967, American reconnaissance satellites photographed a Soviet aircraft at Domodedovo airfield, and the analysts who reviewed the images reached a conclusion that alarmed the entire Western intelligence community. The aircraft appeared capable of Mach 3. It had 4 massive air intakes, enormous vertical tail surfaces, and a fuselage that looked like it had been designed by someone who found compromise offensive. The mig-25P entered service that same year. 2 Tumansky R-15B300 engines producing 24,700 pounds of thrust each with afterburner. Maximum speed Mach 2.83 in sustained flight, with brief excursions beyond Mach 3 that damaged the engines and required complete overhaul afterward. Service ceiling of 74,000 feet. For R-40 missiles. In 1976, Soviet pilot Viktor Belenko defected to Japan in a mig-25P and American engineers spent 2 days taking it apart. What they found reassured and alarmed them equally. The airframe was stainless steel, not titanium. The electronics were vacuum tubes, not transistors. The aircraft had been built for one flight envelope and nothing outside it. It was not the universal supersonic threat they had feared. It was a very fast, very specialized machine that did one thing better than anything else alive: outrunning whatever was sent to stop it. The mig-25 could outrun any missile fired at it. The mig-31 could see everything around it and kill 4 of them at once. Entering service in 1983 as a replacement and successor to the mig-25, The mig-31 used two Soloviev D-30 F6 engines producing 34,170 pounds of thrust each with afterburner. Top speed reached Mach 2.83. The Zaslin passive electronically scanned array radar, the first of its type on any production fighter anywhere in the world, could track 24 targets simultaneously and engage 4 at once with R-33 missiles capable of reaching targets 75 miles away. A two-man crew, pilot and weapons systems officer, working a digital data link that allowed for mig-31s to coordinate intercepts across a 600-mile front. Around 519 were built. The mig-31 was not an upgrade of the mig-25. It was a different answer to a different question. The mig-25 asked how fast the Soviet interceptor could go. The mig-31 asked how much of Soviet airspace a single aircraft could control. The answer was more than anything that had flown before it. The Su-27P was the dedicated air defense interceptor variant of the aircraft that had been designed to counter the F-15 Eagle, and when it entered service in 1985 it gave the Soviet air defense forces something they had never possessed. A fighter that could outturn, outclimb, and outmaneuver its Western counterparts at the altitudes where interception actually happened. Two Saturn AL-31F engines producing 27,557 pounds of thrust each with afterburner. Maximum speed Mach 2.35. Range exceeding 2,300 miles without external tanks. 10 hardpoints carrying R-27 and R-73 missiles. The N-001 Mayak radar tracking targets at ranges that earlier Soviet interceptors had never approached. The Su-27P patrolled the same Arctic approaches the Tu-128 had covered for 2 decades, but with the agility to engage anything it found rather than simply reaching the target area and firing. The Pugachev Cobra maneuver demonstrated at the 1989 Paris Air Show was not a combat technique. It was a statement. The assessment of the Su-27 as a credible threat had been accurate. The test pilot climbed out of the cockpit on February 29, 2000, and the Mikoyan Project 1.44 had made its first flight. It had taken 12 years to reach that runway. A Canard Delta configuration designed to meet the same fifth-generation requirements the Americans had written for the F-22 Raptor. Supercruise capability. Supermaneuverability. Stealth. Advanced avionics. Two Saturn AL-41F engines estimated to produce 39,000 pounds of thrust each with afterburner. A radar cross-section the designers claimed would be competitive with American fifth-generation standards. 2 prototypes were completed. The program was cancelled in 2002 after 5 test flights, as Russia's defense budget collapsed under the weight of the post-Soviet decade and the institutional competition between design bureaus reached a conclusion that engineering had never settled. The 1.44 never entered service. Its engines, its fly-by-wire concepts, and its aerodynamic research went directly into the Su-57 program. The aircraft that lost the competition to itself ended up defining the aircraft that replaced it. The program has no confirmed prototype, no verified first flight date, no publicly released specification that has been independently confirmed. What exists are official Russian statements, defense ministry announcements, and artist renderings of an aircraft designated the mig-41, described as the successor to the mig-31, reportedly capable of Mach 4 or beyond, allegedly designed to intercept hypersonic missiles, possibly carrying directed energy weapons, potentially operable in near-space altitudes above 130,000 feet. Development is said to have begun around 2013. Initial operational capability has been described by Russian officials as achievable in the 2030s. No Western intelligence assessment has confirmed a flying prototype. The mig-31 it is designed to replace is still in production, still being upgraded, still flying the Arctic patrols it has flown for 40 years. The interceptor that began in 1946 with captured German engines and a gun that could flame out its own aircraft has followed a line from the mig-9 to a program that may not yet exist. The Soviet Union built that line. Russia claims to be extending it. Whether the mig-41 ever flies will determine whether the claim is history or announcement.